Hello and welcome to the first episode of my Machine Learning Basics series. In this series, I'm going to cover machine learning as well as some of the math required to understand it. A lot of the mathematical concepts that I'm going to be covering are nothing more complicated than you'd get at grade school math level, but I will be explaining them as if you have no idea what they are. Now, before we begin, we need to set up our environment. For this series, we'll be using Python as our programming language of choice. There are other programming languages that do well with machine learning, but Python is definitely my personal choice, as well as the one that's probably the most popular for machine learning, at least the time of this recording. I will also be using the most recent version of Python 3. So make sure that you have the latest version of Python 3 and that your environment is running and that pip is also set up. We'll need several libraries along this journey. If you don't know how to do any of this, refer to my Python series where I'll explain how to set up your environment as well as how to get pip set up and all the stuff that you'll need to get going there. Now, to get started, we're going to review some mathematical concepts. The first concept we're going to review is kind of mean, median, and mode. This is a common topic when dealing with machine learning, as we're going to be working with distributions and large numeric data sets, etc. So what is mean, median, and mode? Simply put, mean is the average value of a set, median is the midpoint of that set, and mode is the most common seen value of the set. So let's go ahead and I'm gonna drop some code in, and we'll get started on a little bit of testing and seeing mean, median, and mode in code. All right, well, to get started with mean, median, and mode, what we're going to do is first start off with creating a random list here. So what I'd like to do is first start by importing random. The next thing we're going to do is we're going to generate a random sample. So we're just going to call this random list. And this is going to be random.sample. And we want 10 items. And then that's going to be between the ranges of, let's say, just 1 and 100. That'll give us a nice large range set. And this will be different each time we actually run the code, but we can go ahead and just run what we have right now and see what happens. You'll see that it generates a random variable for us here. And if we run it again, that'll update it as well. So we can kind of see what's going on here. So now that we have a list of numbers, we can actually, figure out what we're going to do. So the math is really simple for mean. And so mean is the average. So the way we find an average is we sum everything together and then we divide it by the number of constituent parts. That basically means since we're getting 10 samples, we would take all of these values, add them together, and then divide them by 10. So that means that we could basically do something like, in some pseudocode, we could say like for num in random list, and then we could come over here and say something along the lines of num plus, and we can say something like total equals 0. And then here we can say total plus num. And then we could, once we're done with this, say total divided by 10, because we know there's 10. Otherwise, we could just do the random list.length. And this would give us our mean. So our mean would be this. So let's go ahead and just run it and see what we come up with. Boom. Okay, so now we got each of these variables that we defined here. We can see them in there. Like I said, they're constituent parts here. So it makes it a little bit easier to explain what things are assigned to at runtime. Our mean is 43.9. We would probably want to seal that to 44, which would just round it up. Num here, this is like the most recent num. This is kind of pointless here. The list, these are our list items, and this is our total. And so we can say, oh, divide this by 10, 43. The math looks right. So assuming everything's looking good here, we can do that. Or one of the things that you'll probably be doing when you do this is you don't want to implement like something as basic as mean every single time you need to use it. So what you can do is you can include a library that has a bunch of helper functions and whatnot. In this case, because we're doing machine learning and machine learning really likes some of these algorithmic stuff, we're going to use NumPy. And so what we're going to do here is we're going to import NumPy. And then what I'm going to do is keep our random list here. I'm going to name this mean manually. And then over here, we're going to say mean via NumPy. So what we're going to do is we're going to use NumPy to calculate it. And it's actually like silly easy. All we have to do is say NumPy.mean and pass in our list. So then what we're going to say is we're going to save this as NumPy mean. And then let's just go ahead and rerun the whole thing and see what we come up with. There we go. All right, so if we look at our mean, it's 57.1, and NumPy's mean is 57.1 as well. So we are doing really good. But this just goes to show you that this little function here, this little helper, it's just a shortcut. It does all this for us. It's pre-built, and we can use this in any package or piece of software we want to use. So the next thing we're going to do is I'm going to show you some Midian. Now, yes, Midian is the exact same thing when it comes to NumPy. We can actually just use Midian. For the main thing is here, we could do some math to it. It's a little bit more complicated than mean because obviously we'd have to figure out what our middle value is. And there's a couple of really optimized algorithmic ways we can do that, but I'm not going to dive deep into that. And instead, I'm just going to say, we're going to say NumPy Midian equals NumPy, Mr. Y dot Midian. And then this one's going to be our list as well. So that's going to give us that. So let's just go ahead and rerun this whole thing and get ourselves a new set of data and look for our Midian. I'm going to slide this over, and it is 54.5. So that is the Midian point of our value. Midian is one of those ones that when in machine learning, it's not as important most of the time. You're going to have spreads that are going to be much smaller. Usually you're going to be between 0 and 1 and be using lots of floats as you get more and more advanced. But this is a good kind of show of concept here. And by the way, for those wondering about the math for it, basically what you're going to do is just return the middle number. And if there are two middle numbers, like for example, we have 10 items. So the two middle numbers are going to be, the ones at index, 1/2 and basically 1/2 plus 1. So you can think of that as 10 numbers. We want the item in position. So now that we've done mean and Midian, let's go ahead and take a look at mode. Obviously, mode is kind of the next one in our list of kind of basic math that we want to do. Now, mode is the one that kind of takes the most common number. Now, in this case, because we're doing 10 random out of 1 through 100, there may actually be no normal mode. So, also, NumPy doesn't handle mode, which is kind of interesting. Instead, what we're going to use is we're going to use SciPy. And we're going to say import stats. We're going to pull from SciPy stats. And then if you don't have it installed, you're going to have to pip install SciPy. There's a few things that you should always install: NumPy, SciPy, Pandas, and a few others. We'll get into them, and I'll start using a lot more of them as we go. To calculate mode manually, all we would have to do is create a hash of values and then increment that hash by 1 every time that value is found, and then find which in that hash has the highest value. And it's not a complicated algorithm to write, but it's much easier to just use SciPy's stats. So what we're going to do is we're going to call this one SciPy mode equals, and then we're going to just say stats dot mode, and then we're going to go random list very similarly, and theoretically this should work. So let's go ahead and give it a run. Looks like it did. Let's open up our variables and find our SciPy mode, and you'll see here, if we pull this open, our mode, we have an array of 23 and our count is 1. That's because we had no duplicate results here. So one of the things that we could do is we could add to this random list to make sure that we have a value. So we can say random list dot append, and let's just add 6, and then we will add another 6. And then let's go ahead and run this, and theoretically, statistically, 6 should be our result. There you go, 6, count 2. So what's funny is SciPy mode does exactly what I explained by creating a hash and then counting. And the reason you know that is because you can actually see what modes are in the array and then what the counts are for those modes, which makes it really convenient because it just basically does the math for us. Great. So now that we've seen an example of mean, median, and mode in code, let's go ahead and check out what a standard deviation is. And in essence, a standard deviation is a numerical value, a number, that gives an idea on how spread apart values are from each other. Low standard deviations means that all the numbers are closely clustered, and higher standard deviations means that the numbers are spread out. Calculating the standard deviation is a common thing to do when building or using a machine learning algorithm. So I'll show you a quick example of how to calculate the standard deviation in a set of numbers. An interesting thing to note is that you can find the standard deviation by calculating the square root of a number known as variance. And conversely, you can calculate the variance by multiplying the standard deviation against itself. If you need to know more about the relations between a standard deviation and a variance and the fact that, square root of each other kind of thing, or one is the square root of the other and the other ones, you can find a better place online to look it up. There's all kinds of websites and references and other resources on the internet that will cover them in far more detail than what I'm going to do or why you would want to know these numbers. So let's just go ahead and jump into some of that code. So we're jumping back to NumPy for this one because NumPy has a simple standard deviation function that we're going to use. In this, we're going to say our deviation equals, we'll say numpy.std, and then we will pass in our list. Now, the standard deviation, the actual math behind it is basically we're finding the mean value, and then once we have the mean value, we do some math on the difference between the mean value and each number in the list, and then we calculate those together to create what is the standard deviation. In this case, it's probably going to be a pretty big number because this is a random sample between 1 and 100. If we lower that sample, it'll be a much tighter, or in this case, a lower standard deviation. So let's go ahead and run this and see what we come up with. All right, so what is our deviation? It is a float, of course, and we are at 26.55. So that means that each number is about 26.55 away from the mean, which is almost exactly what we expect in a random list between 1 and 100. We kind of expect everything to cluster in the middle and there to be about a 25 point variance in there. So now what we can do is let's shrink our set, and this will give us a much tighter, or in this case, a lower standard deviation. So it was 26. Whoop. Oh, that doesn't like it that much, because the actual numbers are going to be, there's actually 9 numbers. So let's make this between 1 and 20. And so now, yeah, you see our deviation is actually 5 now. Which again is about what we expect. If everything's in the middle, we're expecting our standard deviation to be about 5. So the math makes sense and it all kind of works out. So there was no actual machine learning in this. These are simple mathematic algorithms. These are things you learn in grade school for the most part. These are really simple things to calculate. And we have libraries to do even some of that simple calculation for us. So it really kind of gives us a lot of power here. One more type of math I do want to cover is percentiles. And while I'm not really going to show you any code for that or anything, the percentiles become very important later and we will be using them. They're fairly important for statistical analysis and just simply getting data out of your numbers. And again, I'm not going to go over how to calculate them all in detail, but it might be worth looking up, like, how do I get the percentiles of a set, those kinds of things, if you're really interested in it. But it's not too important because we'll be using libraries for that in the future, and then I'll cover those in detail when we actually start using them. And that's it for now. I hope you learned something. And in the next video, we're going to do some real machine learning.